Welcome back. In one of our video, we use this reaction type, the Langmuir Hinshelwood Hougen model, to model our kinetics. However, there is similar type also available with the additional word generalized. In this video, we will see how we can use this type and what are the benefits of using this instead of simple kinetics. So this is our reaction kinetics. This is from the steam methane forming reaction, and these are the A and B's of this kinetics. The calculation of these parameters is from the another video. You can watch using the link given in the description or tag appearing just above. So let's start. Just create a blank simulation and select the following components. In the method, select SRK and the free water is steam NBS. Run the property analysis. You shouldn't have any warning or error. Now we can go to the simulation. In the reaction type, we will add a new reaction. You can see there is no GLHHW in this list. So select general and press OK. When you add new reaction in the reaction class, now you can select the desired option. Reaction name say 1, and we have CH4, water, CO and hydrogen, which is steam methane forming reaction. And the reaction is also reversible. Now in the kinetic section, there is a little difference between generalized type and simple as LHHW. In generalized type, you need to define just one adsorption parameter. So we have a absorption parameter 1, exponent 2, we have CO, H2, CH4 and water. In the first term, we don't have any concentration. We just put 0 here. Second term, we have CO. The third term, we have H2. In the fourth term, we have CH4. For CH4. In the fifth term, we have -1 H2. We have CH4 0 and water of 1. It also write the same term below. You can see either it's same as you want. And now here we will define the adsorption constants for the first term. We have 0 here. For the second term, we have -9.4051 and B is 8497. In third term, we have -18.9117 9971. Similarly, fourth term, and the last term 12.0839 -106. Now this adsorption term will be used by each reaction. If you have a multiple reactions for say 2, 3 as shown here. Now in the kinetics term, you can define the kinetics of individual reactions. similarly as we use the method in simple kinetics. Now the denominator term is generalized adsorption. We have a reaction phase of vapor and partial pressure is our basis. Now another thing that is useful in this type is you can select the unit of the driving force. If you see the kinetic parameter of this reaction, you have a pressure unit with the equilibrium constant and adsorption parameter as well. So if you are using this type of model, you can select the unit. Otherwise, you have to convert the bar unit to kilopascal, which is the default unit for LHHW model. So by selecting the unit bar, we can simply need to calculate A and B and put the values here. For the reverse reaction, there are two options here. It will automatically calculate the reverse by using microscopic reversibility, or you can specify the parameters as we used in our previous video. For the forward reaction, we have a 1 methane, 1 water, and minus 2.5 hydrogen. We have 34.6951 minus 28879. And for the reverse reaction, we have 1 CO, 0.5 H2, 4.5818 minus 2049. Our reaction kinetics has been completed. Now you can attach these kinetics in your reactor model and simulate your process. Thank you for watching. Please subscribe my channel for more videos.